Hey, how y'all doing? I am working on a Toyota Camry 2011 power window system. The 2010 and the 2011 are the same. 9 and before and 12 and after, they're not the same, but I haven't proven that myself. The first thing I want to do to start about this system is kind of a lecture, which is kind of bizarre, but it's not your conventional on-off switch. We've entered into the age of computers years ago. I bought my first scanner back in 1983, I think it was, and they'd already been out for a little while. But neither here nor there. I do this professionally, I work on things, but moreover, I have some pretty decent diagnostic skills. Back when Ford came out with computer systems, the four-wheel drive mechanism is the one I'm thinking of. I had to change my thinking about electricity. We usually think in the power steering window that when you flip a switch, there's a 12-volt lead that goes to it, and then if you want it to go up or down, off of that is the wire that goes to a certain portion of the motor, and it has the ability to reverse polarity. And that used to be, but now we have something a little bit different. But going back to my Ford story, the four-wheel drive, the switch that tunes in for two-wheel high, four-wheel high, and four-wheel low. Some of us are going to know how it works and some aren't. But you have to adjust your thinking to it. The electric shift on the dashboard doesn't just have power going through it. The computer reads that by resistance. Let's say two-wheel high, when that switch is in that position, if you read the resistance through that switch, it would be, and this isn't the number, but I'm going to say it, let's say it's 200 ohm. All right, the computer has the logic in it that says, okay, if it's at 200 ohm, I'm going to be in, and it doesn't say two-wheel high, but I'm going to be in this position here. Now, when you switch that to go to four-wheel drive, you're going to be in four-wheel high. That ohms reading on that switch, it goes now to a different selector, and let's say it reads 400 ohms. Okay, computer logic says, I need to switch over to this arrangement here. Likewise, with when you switch that into four-wheel low, let's say it reads 800 ohms. So when you're checking that switch, you're not just reading, you're reading resistance. You're not just reading conductivity. You're not reading power through it, but you have to know the pin configuration to be able to read what the ohms are. You have to be able to read the resistance to see if that switch is any good. I'm sure that there's been a lot of switches replaced because you don't understand that, and that's you collectively as the world. You don't understand that it's reading ohms. It's not a conventional system. Well, the 2011 Toyota Camry is the same thing. I went into this thing. I had a left rear window that wasn't working. And so anyway, I started trying to read the switches, and I come up with, well, I've been chasing this paper for a while. I apologize. I started chasing this system that didn't have any, well, I had a hot lead going over to it, but it really wasn't hot. And I will quite say it like this. It's looking for a ground. All right. Now, I'm going to have to change positions because I lost my schematic, and I'll pick up here in a minute. Okay, I'm going to leave this video on, and I'm trying to give you a shot, and I'm also going to try to include a screenshot on the electrical system on the schematic on this and do some close-ups. All right. If somehow you can take a shot of that and enlarge it on your phone. Now, I'm going to go down to the left rear window, which is what I was working on. As you can see, this is the motor right here. Okay, you see it, the wire connections coming in, and that they're going over to the switch. Now what you see by this is that you've got a power lead coming in, and you've got a ground. If you study that, you got a power lead coming in and a ground going to the motor, and then you've got wires going off to the switch. All right, now that's kind of a basic study right there. Now I'm going to move over to what I actually worked out for you to take a look at. This is the motor right here. This is what a connection will look like right here. Now I've done it in short, and this wire goes to your switch, this goes to your motor. Now the diagnostics is what I'm going to be covering on this first, and basically to see if you've got a good motor, you got a good switch. The wires, the three players in this are, well, there's four. You've got power coming to it, and your ground is just as important as your power. On the schematic, it'll tell you where your fuses are. On this, you have the motor, which they actually call an ECU, which I would suppose electric control unit. Inside of this unit is, well, I got the lid of it off right here. And I would suppose that in here, they have the power, I would imagine a printed circuit board of some kind, and a transistor enough to change the polarity of the motor. That's where all your workings are. You've got wires that go off to the harness, to the back switch, which is in the door, pretty short set of wire harness. And then you've got one that comes down from the front left master switch. Haven't worked into yet how all that works. I'm working with components that I replaced, and now I'm proving the system. Okay guys, I'm doing this the best I can. It's free too, how about that? All right, now here's essentially it. Like I said, schematic, I showed you the schematic. You're gonna have to look at that. Right here is your hot lead going into a motor. That's fed off a fuse from the dashboard. Okay, we're gonna just set this up. Right here is ground. It's white with a black tracer. Now, that ECU is hot. That is hot. I've got another ground to come off here. Basically, I'm going to show you, if you look at the schematic, it says that the red wire and the dark green wire. Now there's not too much difference between light green and dark green, but you're gonna have to be careful of that. Take a look in and see how it separates. But essentially, to check and see if your motor is good on both the up and down side. Now you're not gonna see the motor run, but hopefully you're gonna hear it. All right, red wire is the up wire, second pin in. Now you can just take that off your switch while it's in the vehicle and just run it to ground. Okay, motor running. All right, same thing with the green wire, dark green wire, which is supposed to be, I forgot now, up or down. All right, with that said, I can pin that. Okay, you hear it running. Okay, now the auto run, and I haven't quite figured out how that works. Remember, I'm only diagnosing components, whether they're bad or whether they're good. This right here, the black, somehow on the schematic, if you look at it, ties in with when it goes all the way up. This switch has two triggers on it. If you pull it to this one right here, that is your momentary, and if you pull it all the way up, it goes into auto. Same way with the down motion. If you give it a click, and then you go one more, that goes into your auto mode. When I plug this in, it doesn't quite work that way. I'm showing you, without the switch, I made that motor work. Again, you have to get the schematic, have to look at the schematic, but the red and the green are up and down. If you were in a situation where the window was down and wouldn't go up, you got the door panel off of it, you can pull your back off the switch, and you can make it go up or down. Now, this right here is your ground, white with black. If I connect it to that, you notice I don't have any hot leads going to it. If I connect the switch in, I can make it run. Of course I can. Excuse me just a moment. There. Okay, that's up and down. Now, by theory, if I hit that down automatic, it should run all the time. Haven't figured that one out. Again, I'm just diagnosing. I would say this is a good motor, unless you're having a momentary problem with it to where when it stops, next time you go out to fire it up, it doesn't go. It's better to replace it. I'm hoping to do a part 2 to pull this motor apart to see what the board looks like and to see when they go bad, if it isn't just a transistor that goes bad that selects up or down. All right. Now, to check your switch, all right, I'm going to disconnect this. And, excuse me, the world just shook. I'm going to disconnect this here. And this is where I was. And guys, it took me about 3 days, not 8 hours a day, but it took me 3 hours of farting with it to three days of farting with it to figure out, prayed about it, and by golly, came up with, I was thinking about it in a different way. Well, okay, there we go. To check the continuity on the switch, I'm going to shut this off just a moment and bring my ohm meter up and show you how this is working and how I figured it out. Thank you. All right, I guess we're filming again. All right, this is my switch test. If you noticed, there again, you use the harness right in the vehicle. I'm using the red and green lead. Now, if you check the continuity of these wires, because sometimes wires do get broken from doors opening and closing all the time, rats, certain, whatever. If you want to check the continuity, you just go ahead and pull it off at the switch and pull it off at the motor and check if you get readings all the way through. I would probably say the best thing to do is go into your wife's sewing room and get your best testing equipment. And if it doesn't get back there or if it's dirty, you really are going to get reamed buckwheats. And I'll tell you that. But here's what I'm showing you on this switch. I have got a lead connected to ground. That's the white with black tracer. I'm not connected to any of the other wires except the one that says up, which is my red wire. Now, to show you that this thing works off of seeking a ground, it isn't a power going through this. If you test probe it with a meter, with a test probe light, you're going to get a wire that's looking for a ground. In other words, you'll have one light up that will come up on your probe as red. It's hot, but there's no power behind it. It's looking for a ground. And that's why I'm doing this. Take the clip off your motor, stick it into the up switch, take your one lead to ground, and I've made it simple for myself there. You would just merely probe it. And if you notice, when I push down, nothing changes on the meter. I hope you can see that. But now if I lift up on it, watch. Boom, goes to ground. And it's the same way with the dark green. If I take dark green, which is my, I'll take this all the way out so it doesn't hit it and you can see that I'm not going, goes back in the pin cushion, unsoiled. And I think I did up before. Let me do this again. Okay, up, nothing happens, changes on the meter. But if I go down, it's looking for a ground. That tells me this switch is working properly. The auto may not be working, but at least I can make the motor work. And there again, I'm looking for components that aren't working. The motor will work in the back if the front master switch isn't good. But the parts on these things are inexpensive. They're not like your $30 or $40 items anymore. going from Toyota, that front left master switch cost $750. I don't know what planet they came off of, but you know, that's the way it is. Okay, that's the testing of your switch. There again, if I plug that back into the motor, we're back to where we were. And I guess that's what I've accomplished on this time around. Just for you to see just the simple diagnostics, or to get yourself out of trouble if the window's down and it needs to go up. There it is. I hope this helps you. You just got about 3 days of my ponderance and chasing schematics and so on and so forth. There doesn't seem to be any of this. I found nothing on the internet about how it actually works. So I hope that this is some introduction to it. If you have any feedback, my goodness, if you find something, share it with me. All right, I'd greatly appreciate it. Thank you, guys. Have a great day.